first Vice President Ralph to introduce our first speaker tonight.
He's going to do a little tap dance while I get my computer open.
I'm going to turn over pretty fast. This is Bob Trembley. He's our current outreach chair, past publications chair. And if you know the club, you know Bob has an understated style of enthusiasm for asteroids and everything that says con on the end of it. So he's going to talk about Juno. The mission that was mentioned by Ken earlier, and give us a little insight.
What if you know to be married now? What do you need?
It's clicking.
I thought that was my face, man. It's like the crocodile in Peter Pan. Right. That's something funny. Yeah.
Ralph's not doing the tap dance.
You don't want to see that.
All right. Here. All right. This is the warm-up act here.
Yep.
In June,
All right, so.
special event at
I'm
the
going
Vatican
to,
Observatory. Starbecue. See me. That's right, Starbecue. And you can sleep at Kissing Rock Farm, where, as I've said numerous times, I can put up an unlimited number of people at a medieval level of comfort. But it's open bar. Right? 22nd of June, Vatican Observatory, Grand Rapids Astronomical Association, of which I am one of the more prominent and accomplished members. Thank you very much for your attention.
Thank you, Gary.
Okay. So during the formation of the solar system, I'm skipping the whole part of the protoplanetary disk stuff. The sun gathered up 99% of the material in the disk that formed the solar system. And Jupiter took up more than half the remaining material. So, and the leftovers of the leftovers formed the rest of the planets, asteroid comets, and et cetera, et cetera. So Jupiter is the largest of the planets. It probably formed first before the other planets and may have been responsible for the distribution of water throughout the early solar system. The composition of the Sun and Jupiter is very much the same. And Jupiter holds on to the early history of the solar system, where the Earth lost it through climate and such. So the Jupiter is holding on to that. So in 1995, the Galileo orbiter dropped an atmospheric probe down into Jupiter's atmosphere. And there it is. It looks a lot like a submarine, and it was designed for very high pressure. Galileo failed to find any water. The Galileo data shows a ratio of elements in Jupiter compared to the Sun. The line there, the 1, if the elements were the same, the elements would be on that line. So what we've got there is helium is depleted compared to the Sun. The hypothesis said that helium would rain down towards the middle of the planet, and neon would dissolve in the helium and get carried down. And this data nearly matched the hypothesis. The rest of the elements are at an elevated or enriched level compared to the Sun. Every hypothesis about how Jupiter formed was proven wrong by the Galileo data. And note the red indicator, that is for water, and that was depleted. Now they're thinking maybe the probe fell into a hot spot, a desert, if you will, something like that. Or maybe it didn't go deep enough and find water dredged up into the atmosphere. We need to go deeper. About the time of Galileo, we started discovering exoplanets, and we discovered giant planets that were way too close to their star to have formed there. And the idea of planetary migration came into play, with Jupiter forming out in a colder environment, migrating inward and scattering the remnants of the protoplanetary disk all over the place. And this, by the way, is maybe what happened to Ceres and why it's such an oddball in the asteroid belt. That's another lecture. Jupiter's migration, yeah, they've been responsible for the water. Okay, Juno was launched in August of 2011. It did a gravity assist by the Earth in 2013, performed some deep space maneuvers, been cruising for nearly 5 years. Juno is the first solar-powered mission to Jupiter. It is quite large. Its solar panels are 8 meters long. It is the fastest man-made object in history. Here it is today. This is from NASA Eyes on the Solar System. And you can see it's approaching, getting close to Jupiter there. Here's another angle of it. It's coming in at Jupiter from slightly above the plane of the ecliptic. Juno is going to investigate the origins of Jupiter and look deep into the planet to find how much water is present. It will investigate how the enrichment of oxygen compares to the other heavy elements, heavy being elements other than hydrogen and helium. Juno will use gravity science to peer into Jupiter's deep interior and take a look at its core. If Jupiter does not have a dense core, it may have formed much earlier than previously thought. That's what the scientists are saying anyway. Juno will probe the depths of Jupiter's atmosphere at all latitudes, and it will map the structure of Jupiter's huge magnetosphere. And here's an example of Earth's magnetosphere. This is done in Universe Sandbox. You can see the envelope, it's kind of stretched, kind of like that egg shape. That's Jupiter's magnetosphere, and you can't tell it that much. So let's zoom out. And that's Jupiter.
Yeah.
So Jupiter's magnetosphere is like Earth's on steroids. Here's the initial orbits. Initial orbits in white will avoid the radiation course around Jupiter. As the mission continues, that orbit's going to start dipping into higher regions of radiation. Juno will orbit Jupiter 32 times, each lasting about 2 weeks. It is going to pass within 5,000 kilometers of Jupiter's cloud tops, and maybe a little closer, yeah. Juno's orbits will cover the entire face of Jupiter. Showing you this map shows an example of that. Juno's electronics are housed in a titanium vault to protect it from Jupiter's harsh radiation. And this allows for the use of designs from previous NASA missions, which is convenient. Next. Look at the spinny thing. Oh, technology is failing.
You got too close to Jupiter.
So I got it.
You are getting too much radiation.
I am. It's all bright. It's coming right at me. Let's see, not responding. I think Carbon just took it off.
That's why I like keynotes. $1 billion space.
I don't have a Mac. I don't have keynote.
Macs don't do that.
What number? Almost.
Sorry about the tech problem.
Sorry about
There you go.
There we go.
Benny Hill music. I should have that there to queue up. Magnetosphere. There. Alright. So 5,000 kilometers. Imagine entire surface of ball. Alright.
Next.
Wow, it doesn't like to slide. Okay. Okay, Juno is going to be in a polar orbit, and the polar orbits provide complete mapping of the planet's asymmetric and highly structured magnetic field. Precise magnetic measurements unveil fundamental processes that generate the planet's powerful magnetic field, including clues about what conditions are like at the depths the field is created. Juno passes directly through the lines of Jupiter's magnetic fields, which cause the planet's auroral displays. Juno will measure these particles precipitating into the atmosphere, and it will image the aurora in infrared and ultraviolet. Juno carries some very special guests on its journey to Jupiter. It has 3 Lego minifigures made of aluminum along for the ride of Galileo, Juno, and Jupiter. And there's a plaque bearing Galileo's likeness and his handwritten notes celebrating the astronomer's great contributions and commemorates the discovery of Galileo's large moons. So Juno is going to burn up in Jupiter's atmosphere, ending a mission in February of 2018. It is the second spacecraft designed under NASA's New Frontiers program, the first being the New Horizons Pluto flyby. The third mission will be the OSIRIS-REx asteroid sample return mission. So here's a location of the various instruments and a human for comparison. Like I said, it's a pretty large spacecraft. And one of the instruments is named Jedi, and I'm so glad you're here.
So many people like you are now employed in the space program.
I wish. There's a lot of outreach materials available for Juno. The spacecraft has a camera for education and public outreach that they will be accepting requests for. What do you want us to photograph? So, what do we want them to photograph? I'll submit it for us. Juno, here's this mission website. They are all over social media. And you can fly along with Juno's mission using NASA's interactive Eyes on the Solar System. And I can have that running during the break. Pretty cool, actually. And that's it for Juno. Video time. Tech file.
Can I ask you
Yes.
a question?
All right, I can't see anything.
Well, they're
Jonathan.
Go ahead.
How did they decide how many orbits to do? I was kind of hoping until you got to the end that there would be an extended mission, but obviously.
No, it's going to be dipping into those with that radiation first. Let me turn this guy right here. Slideshow from current. That guy. That's the Io radiation torus, and it's going to start off in the newer, less intense regions. But according to the teleconference I listened to, Jupiter's gravity is going to be dragging it down lower over the course of the mission. It's going to be going through those red regions, which are higher radiation. And yeah, it was never meant to have an extended mission.
What I find fascinating is that they're the polar footprints of the 3 closest satellites, right? And
In the aurora?
Yeah, in the aurora. Is this a hypothesis or this been observed?
What, the auroral footprints? No,
Yeah.
they've observed those guys.
It's
Yeah,
amazing.
Yeah, this is going to be the first spacecraft to image polar
Right,
regions,
I know.
which is going to be very cool.
Direct them all, right. That's fascinating.
Two more questions.
Okay. As the satellite or as the probe goes down, is it going to burn up due to velocity in the atmosphere?
Oh yeah.
Or is it going to get how deep do you expect it to go?
Oh, it's probably not going to be very deep at
I
all.
don't think you'll get a chance to burn.
No, this was not like the Galileo probe. It was not meant to withstand re-entry. It's going to burn up very high.
So how far do you expect it to?
I'm not expecting it to go very deep at all. I can find out for you, but yes.
There's got to be something like a synchrotron inside Jupiter's core to
That's-
generate that much electromagnetic, to generate such an electromagnetic field?
Well, you've got.
What did people think it was before?
I'm not sure what they thought it was before, but I know what they think it is now. Is like 2/3 of the planet is made up with liquid metallic hydrogen that rotates in
Oh,
10
okay,
hours.
yeah, yeah, that'll do it.
That generates your huge magnetic field. When was the
Oh, one other one. There isn't enough hydrogen there to ignite, right?
No.
So the end of 2010, The Space Odyssey, is absolutely pure fiction.
Yes.
Can't have a second star.
They were teleporting mass in from out system.
Ah.
Yeah.
Okay.
Science fiction.
One more.
Yes.
You said that it's the fastest man-made object. I thought New Horizons was the fastest man-made object.
No, that's what the, I'll find out for sure, but
I
that's what
believe
they-
as of this recently, it was
Yeah.
overtaken by Juno.
Really?
Yes,
Very recent, very recently.
last couple of months.
It's melancholia. Oops, slipped out.
Ah,
It slipped right out.
well, another round of applause for Bob.
What, Ken's gonna talk some more?
All right.